Hello, everybody. Are we live? We are live, I think. We are. Yeah, and you can hear me. How's it going, everybody? Hey, look, recursion. Ooh, a little bit of a delay. Not too shabby. Fun stuff. All right. Well, I think we should just get into it right after making our Discord announcement. It's basically going to be this. Red circle live. Link to here where we are live. Compiler for fun. Part 2. Looks like we have done it. It's a good sign. All right. Now that we're officially live, we can begin working on the compiler, I guess. That's where we're at. Streamer. Angel, so good to see you. Thank you for showing up again. I really appreciate it. I'll warn you, I didn't get enough sleep last night, so if I don't talk enough, you gotta poke me. Say, hey, you're too quiet. How's it going for you, Angel? That's okay. That's about how it is for me. It's like, each day it's okay. There's another day after it, and there was one before it. Not much more to say about it. I feel you. Okay. I'm just scanning this code, trying to remember what I did. All right, so yeah, there should have been a to-do statement or something here. So we need an API to create a new environment. We have some to-do messages we can definitely tackle. But overall, let's see if this program compiles and runs, right? How do we do that? I believe I used CMake. Streamer. What is this? The fun compiler? Yeah, we're working on the compiler. And let's see, what is it? Probably just called build. Compiling. It compiled and generated func.exe, so let's try and run that. Where is that? Build. It's within the build tree. Okay, so maybe when we compile it, is this just a shell command? Can we tack on something here? Like, oop, yep, not like that. Okay, yep, there we go. And we're back. I think I need to copy this and then just put the executable. Let's do it. Yeah. Perfect. And look, now we compile and then run our program. So path to file to compile. That's a funny way to say that. So our program spit out an error message, probably print usage, wherever that is. Yeah, we just saw this error message, so we didn't use it, right? We have to pass the path to file to compile. Okay, so let's say we want to compile example, so we're going to have to do another one of those paths. That one. but it's not going to be build. It's going to be example. Oh, look at that. Okay. It compiles and runs. We did it. That's pretty good. So we have, let's take a look at our source. Can I do like this? Looks so cool. Thank you, my guy. That's awesome. I agree. It's like, oh, it's working. So this gets converted into exactly what we need. Yeah. So we have an A, a colon, an integer. Not an integer, but the word integer, which is going to be a keyword. We have equal and 0. I'm just doing some manual checking to make sure we're not missing something. We have A, we have colon equals. Should we split that into 2 tokens like that, or should we make colon equals like a single token? I think this is fine, because we're going to be saving a list of tokens to, yeah, it's fine. So we have colon equals 0, then we should get B, yes, colon integer, B, colon equals 0, yes, defun, okay, yes. Cool. I think this works. That's awesome. So we have kind of an AST mocked out, but it's not, I guess the node is pretty good. We decided on children. So instead of a binary tree, we're going to have children, which is good for ternary and unary operators, or ones that don't have any children. They don't require to be any larger than a single pointer. So node is going to be 24 bytes. You can see an egglet at the bottom there, which is awesome. So now we just need to start working. I think we need to save tokens. So this should not return a beginning and end, but it should return a structure, which is like a token. I'm not creative. Let's just type def this to make it easy on ourselves. We're just going to make it a linked list to make it easier on ourselves, even easier. Okay, and let's see. We're going to need a beginning, right? And an end. I'm going to type that out since it's not just a parameter anymore. So we have beginning, end. I guess it would be, would it be beneficial? It probably would not be beneficial in the Lexer to save byte offsets, because we lex over and over again while we parse. So we'd get bad. So we actually have to do location stuff in the AST. So when we store, you know when you get an error message from a compiler? Like if I do this, right? And then I try and compile it. What's mean type def struct? I'll get to that right after this. Great question, Angel. Thank you for asking it. So you see how the compiler points you to the path to the file, and then the line on the file, 186, and then even the column offset of the file. It's on the first character. Isn't that amazing? So it tells you exactly, and Emacs is smart enough to go, oh, there's an error here, and it jumps here and goes, hey, there's an error. It warns you. I think that's Egglet working with ClangD. But if I hover over extraneous closing brace, it tells me exactly what's wrong, because it knows expected identifier or blah before blah token. It's saying this is not expected. What is this? So if I remove it, it will compile and run. That's awesome. Basically, the compiler needs to know the location of like where it gets these things from, like where it got this token from. But I think the Lexer isn't in the right state right now to do that, unless we had like a global state, which I don't think we want. So this is what we're going to do. We're just going to have locations baked into the AST, like a node. We're going to add a location structure here with like a file path, a byte offset, and or a line count, or whatever we want to do. It's all doable. Now, to get to your question, Angel, great question. Typedef struct. Okay, so in C, you can have a struct, right? You can name it anything. This is technically a tag, but it doesn't matter. We'll call it a name or an identifier because it identifies this struct uniquely. You can't repeat them. I can't say struct token because if we hover, redefinition of token. So we can't use this identifier in two places as two different things. Token now refers to this struct and this struct only, just by using the struct tag. So it begs to differ, why do we need, if we name it something different, like if we're making a sandcastle, why do we need the typedef? And the answer is actually so that in C, you have to explicitly say when something is a struct and when something versus when something isn't. So if I was going to pass it as a parameter, a token, it would have to look like this, struct token, and then the name of the variable. And I don't like having struct token all over the place when I just want a token. I know token is a structure that I made. I wrote the code. It's fine. So I can remove struct only if there's a typedef here, because we are now defining a new type called token to the definition of struct token with this. So this struct is being typedefed like that, if that makes sense. So we get a new type in C called token with this value. So you actually just get to say struct token when you're putting token. It's kind of just an alias. But this allows for much easier to write code, I would say. I think easier to read is probably arguable, but easier to write for sure. But you see that the typedef isn't a completed expression within the definition of the struct, so you still have to use the struct if you're going to use a linked list. It's pretty funny. C is an odd one. Why can't they just do multiple passes? I don't know, but it's whatever. So this is effectively, maybe we just say token pointer token, right? We're breaking things. We would like to say, whoops, not sure what happened there. It went one off. That was weird. So the dereference now moves into the arrow operator, this dereference operator, instead of the star. So we're still effectively doing the same thing. This is also much more readable. This is like really, did I just swap them wrong? I don't know. It doesn't matter. So if token end, was that what that was? Yeah, so if token, sorry, just doing some refactoring. Okay. single star, once again, single dereference. Was that end or beginning? Oh, Christ. Okay, that was end. Oh, yeah. We're having fun today. We're actually, this is good. We're making progress. This is going to be cool. It's going to be very cool. I'm excited. I don't know if I was excited 10 minutes ago, but I'm excited now. That's what a little bit of coding can do for you. You get excited. Because everybody knows coding is the most exciting thing in the world, right? There's nothing you can do. It's like an action movie. I appreciate you, Angel. Coding is awesome. That's right. It gets me excited. I get excited. I would be that, like, weird guy that comes into class and, like, talks to the middle schoolers, and I'm like, coding is exciting. I get excited. That'd be hilarious. Coding is awesome, though. And I do get excited. It's just funny to laugh about. So where do we call Lex now? Whoa. Where do we call Lex? Here. So now we need to create a token. Token. I should probably have a thing for this. Right? So now I need to say, ooh, I should probably just do this up here. Okay, that didn't. Christ. Yeah, that's better. This makes more sense. So next equals null, beginning equals something, and end equals something. And I think they both equal source, so I can do this, source. Wonderful. Okay, so while Lex token.end, so that's a pointer. And Lex into the token, please. Whoop. Beginning. I get excited. Oh, that's so fun. We're gonna be saying that later, and everybody's gonna be have no idea what we're talking about. They're gonna be like, are they? What's going on? But we get excited, is the thing. Still don't know why it's so funny to me. Holy crap, did that just work? Chat. Angel. Oh my lord. Is that the same? That's the same as before, right? Oh, this gets me excited. Oh, that's awesome. Thank you, Angel. You're the best. It is the same. That's wonderful, wonderful to hear. So we did it. We just refactored into tokens in a linked list of them, and it's fine. So now we just need to actually use the linked list part, right? Yeah. Easy peasy. So let's think about this. Yeah, it's same, but exciting. It's true. Because now we have our custom structure. We're not just using a character pointer, we're using tokens. Tokens get me excited. This is bothering me a little bit. It really doesn't matter, but I have to. Okay, thank you. That helps me a lot. So, oh, little bit more. A little bit. Okay, we're just gonna make you smaller. Yeah, that works. Okay, so we can now parse expressions into tokens. Or well, we really parse source code into tokens. So we lex it. And then each time this token right here on the stack is filled with the data for what we need. Yes. So now, okay, now I get what we need to do. So this is like our current token. We're going to rename this. Thank you, language servers, for letting this happen. Boink, and it's renamed. Ooh, it's a little bit longer now. A little bit smaller. There we go. You even bumped this over. Nice. Okay. That line is too long. That's better. Okay. So see, if this was C++, I could put a member function in the struct and say, hey, to get the length of it, just do end minus beginning. But this is C, so we can't, we don't have that luxury. Okay, so now we have a current token. We need to go up to where tokens are defined and say we need to create a new token. I'm not creative. We're just going to do this. Token underscore create. Looks good to me. We're going to need nothing. We're just going to return an mallocated token. Token pointer token equals malloc size of token. Can you imagine writing struct token everywhere here? This would get real ugly. We're just going to assert token and but not allocate memory for token. So this will just ensure that if this ever fails, our program crashes. Because our compiler, if it's trying to, it can't allocate a token, then we're going to have serious issues trying to allocate an entire abstract syntax tree from the tokens that we can't allocate. We could eventually make this like a return error and everything, but it's not important. Because if you ever fail to malloc just by creating tokens, it would mean we screwed up and we're creating tokens in a while loop forever. Or it would mean that some other program has a memory leak and is eating up all the memory, or it programs, like on Windows. It's like, how many programs can we run at once is Windows question. Linux is like, yeah, we run about 4 processes. One of them is init. And then we just need to return token. But first, we need to, I'm just going to use memset because it's easy. I don't need to do that. I'm going to set the memory to 0 so that everything is null. All the pointers are null. Ain't that wonderful? Yeah. I think that looks good. We allocate memory on the heap. We assert that it exists and is not null, so we don't fail. And then we set the memory to 0 and return our pointer that we got. So this never returns null. Ain't that fun? If we had references, we could do that. I mean, not technically in C++, those types of references, but if we could just use references like a C type, which would be really sweet, we could ensure that this is never null. Because you think they could tell, like, oh, there's an assert before a return on the same value. So that means it's never null. But the compiler's not smart enough because it doesn't follow, it follows the C standard, which isn't like written for the user. So we can now create a token, and all we have to do is say token pointer tokens equals, what is this? Probably null, right? Yes. Maybe we'll take in a token and copy from that. I kind of like that idea. Yeah. Or we could just have token. We'll copy the token ourselves. We can just create, then copy in the parser. It's fine. We don't need to create a function for everything. I'm excited. Okay. Point meet you. You can just dereference the pointer somewhere to make the C compiler assume it can't be a null. True. Wait, is that true? Is that, I mean, it would also fail at runtime, I guess. Assert just lets you control the message people get. It's great to see you, point meet you. First time chat. How's it going? How are you this morning? It's morning for me. Is it morning for you? Okay, we need to create a token in the parser. Yeah, so we need to say when we lex a token, tokens equals token create. And then we're going to have this, like the rest of the tokens. What's a good name for this? Rest of tokens. That's a terrible name for this. Tokens backup. I don't know. We're going with rest of tokens. It's in the evening for me. Nice. We're on like probably 16-hour different time scales. That's very cool. It's cool to see you. I'm glad you're tuning in your evening. As we code a compiler, just for fun. So we replace the tokens pointer with a new one. You need to copy, mem copy, going to be the size of a token. And it's going to be into tokens from the current token. The address of it, because that's stack variable. Wonderful. Mem copy tokens, current token, size of token. I think that works. So from current token into tokens, we will copy size of token bytes, which is like 24 bytes or something. Then we need to set the next value of it to the rest of the tokens. Whoops. Does that make sense? I think that makes sense. So we save our current only to set the next to it. So we add to the head of this linked list. So let me just make sure in my head that this works. So we're going to start with something like null. And then we're going to have rest of tokens set to assigned to that. Then we're going to create some token. That's going to be tokens. And then we point tokens to, yeah. So then at the beginning, it'll point to null. and then it'll point, yeah, that works. Just ensuring my logic isn't flawed here. This can never return null, so we don't have to worry about it. I think that's about as concise as we can get. Now, we should probably have like a print tokens thing so that we know we're not crazy. Probably should have called it token print, but it doesn't matter. Sure. We're just going to be recursive right now. We're not going to do any like continuation stuff, but if you want to learn about continuations, chat, we will do it. We'll make a silly optimized print tokens function. So we have root. Honestly, it might not, continuations, now the more I say talk about continuations, the more likely I am to do them. I'm gonna just do it. So we can just do this. And that's a continuation. That should work. So now there's no recursive call. The stack won't grow. We'll just keep calling this sequentially, returning. Doop, boop, 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 boop. It'll make a sawtooth-sized stack. That's fine with me. No stack overflows happen with sawtooths. Okay, so now we just need to print the values. So we should say if root beginning, print that. There's going to be a few of those. That's not an else. What am I thinking? Okay. Effective. And we're just going to print the string at the beginning and the string at the end, but this won't work really. This would be very ugly formatting. So let's just do a token. Sure. Okay, so now we can say token count, and then we'll do beginning, and then if we do the end, we'll do it after a comma. How's that look, chat? I think this looks good. I think we can print out this list of tokens like this, and it won't look too bad. Oop, I'm wrong. That's pretty important. We need a new line. There we go. Now it looks good. We will write token, string, another string, end. We'll count as we go. We can even say like, if count is greater than 1,000, 10,000, break. We'll just put in a little protection for ourselves for infinite loops. I don't think we're gonna break 10,000 tokens very soon. And we'll just add a fixed one. Remove this line. Remove this line. I don't like putting comments at the end. We're gonna put that there. Perfect. So now we're gonna print tokens after we gather them. So that's just gonna be in the parser, I guess, to test. Okay, hopefully we see some output. Okay, something happened. Ah, yes, I remember now. This is an interesting one. We appear okay, I get it. I get it. I didn't take into account the end of the token. That's my bad. So, yeah. These aren't separate strings. These are the same string. I'm a little loopy today. This morning. Ooh, okay, that should be much more sensible. Hey, look at us. They're reversed, of course, because of how we added them. I don't think that matters at the current moment. We could reverse the linked list. I don't think that's too harsh of a thing, or we could just add them differently. That might be the way to go. I think this is looking good. We get the same thing. It's just reversed. Yeah. Okay, wonderful. Since it's a linked list, we're going to iterate the tokens. I kind of want to iterate them forward, like logically forward. So we can either reverse this entire list, which doesn't feel like the right thing to do. I feel like reversing the entire list could get very inefficient very quickly, like probably n squared timing. So time complexity. So let's think about how we could do this a little more efficiently. We could add them differently. So instead of adding to the head like we do here, we'd have to add to the end, which means that we need an iterator Is it a pointer to a pointer? Let's think about this. What does this iterator need to do? So instead of this, we're just going to all of that right now. Work above it. That'll help, I believe. So we have tokens, and we need it to point to the new one. Okay, so if tokens, I think I can do this. So if tokens exists, write into tokens next. I'm going to say overwrite. Is overwrite one word? I don't think we need that then. Or we can just overwrite tokens. I think this is logical. Okay, so okay. That's literally this line here. And the idea is if tokens is null, there's nothing else in the list to deal with. So all we have to ensure is that current token next is null. And we should be good to go. So this is the start of our list. Otherwise, next equals tokens create. I still set it there too. Hilarious. That should work. It may not work, but it should work in my head. It didn't work at all. We point to the beginning, then we point to the end. Okay. Oh, that's fair, because this isn't the iterator. Look at me go. Look at me go. That would just mean it equals null. So I should probably have it equal token so that it equals something. Okay, so then we have a token iterator that points to the first in the list. So we set the next one after that. And then we say this equals the next one, so that the next time around, token iterator will be equal to the end of the list, and we can keep adding to the next of the end of the list. Okay. Hey, haha. Aug, we did it. So we officially now add to the end of the linked list. Fantastic. I think that's looking right. Yep. Wonderful. Now we don't have to do this lext crop. Perfect. Much simpler. This only gets used once, which is kind of unfortunate. We could always start with like a token at the beginning and avoid this entire branch. Ooh, that's tempting. That's tempting. We're not going to do it. We're not going to do it. We're just going to add a to-do, or fix me, actually. This could be removed from the loop. This conditional branch. Sure. Because we truthfully, if we set up tokens outside of the loop, then we could just use the iterator, and we wouldn't even need this check or this code. We would just need these 3 lines, which would make it much more efficient. It's fine. There's a fix me. We did it. So now we print the tokens, and now we should probably just create an iterator. Ooh. Here's what we should do first. Is this, where are we? No, it's a little too big. We're also going to have free tokens. And no, this doesn't just dispense free tokens. We actually have to free the memory we allocate up here. So we can say while root token next. Well, we'll do token to free equals root. Root equals root next. Free token to free. So now we use the pointer, we dereference it, then we free it. So this is not a use after free. And then we should say to actually replace this with it, and then say token pointer it equal root. I guess that would have to be a token pointer pointer. I'm not going to do it. I was thinking that I could set the pointer to null, but it's too much work. I don't think it's worth it. We'll just understand that the tokens are no longer in use. Rename it to root, I think is what it was. So we free all the tokens in the list. I think that would work. So after we're done with them, we can free the tokens. And loop over. Do I still have token iterator? I do, so I can just use that one. Okay, I'll just compile that. And hey, it runs. And on Windows, that means I didn't free any bad memory. Wonderful. So now we are breaking it into custom token structures that we should loop over and try and fit the constructs of our fun little language to these tokens to construct a tree out of nodes. Okay, yeah, sounds simple. So first we just need to loop over the tokens. I think we can do that. What did I just write? ASTs. Okay, so we loop over the tokens. And while we do that, what do we need to do? We need to, I guess, just map constructs from the language and attempt to create nodes. Okay, so that's right. We need a node root. And this will be a create program node. I don't know. Node program. Maybe we'll just say it's a node. And then we will say, I'm going to use calix so that it's set to 0. I would say there's one node. We can assert the root. I didn't put a period at the end of the last one. Okay, we are making progress on our compiler. Look at this. So we are actually beginning to loop over our created tokens and attempt to create an AST. Okay, let's see how we can do this. So let's try and get a string just to help ourselves. And this is going to be the size of the token iterator end minus token iterator beginning. And then plus 1. So let's actually do that as a separate thing. Token length equals this here. So now we have the token length, the contents of it in an allocated buffer. We can just assert that. I guess that's not how string views work. String for token contents. Let's see. Sure. These error messages really just need to be specific enough that a GitHub issue will tell me where to go. Okay, so we would like to copy into our token content string the size of our token from the beginning. And then we need to make sure that the contents at the length is equal to a null terminator. Okay. That was a lot of work, but we now have a lot of data that we did not before. And now we can use this in string compare, which I think is the way to go. Or we could start making tokens into enumerators and have the Lexer be able to... By the way, you are typing so fast. Thank you. I've been typing for probably over 15 years, so I appreciate that. It comes with time. Plus, all the keyboards are in the same layout, so it really helps. But I appreciate that a lot, my guy. Thank you, Angel. But yeah, doing all these string compares obviously isn't ideal, but it's not really that important because string compare isn't necessarily inefficient. It's just if people start using long names and we start using long test strings. How many words can you type in a minute? I don't know. I haven't done that. That would be fun. Oh, I missed a follow by Point Meet You. How could I? I feel so bad. Thank you so much for the follow, Point Meet You. If you're still here, I really appreciate you. You're the best for sticking around even after I ignored you. I really appreciate it. If you want, there's a Discord down below where all viewers can join and hang out, chat with each other, chat with me. And there's also announcements every time I go live, and that's a much more reliable way to get notifications when I go live. Twitch is kind of iffy on it. And then we just need to compare this to... But yeah, that would be fun. Maybe we should do that on stream someday. See how many words I can type in a minute. Type test. Ooh. Is that a website? It's probably a good one. We are doing good. Okay, so let's see. If it's a colon, okay, I'm just gonna run the program. It's called 10 Fingers. It's a website. Okay. I'll have to definitely try that out. Thank you, Angel. 10fastfingers.com. Nice. That I feel like that's a porn website link, but I'll definitely check it out on my own time. 10 fast fingers. Okay. So we have tokens in a row, and we need to do something with them. We can find when there's a colon and say, hey, we should run some code. So a colon, I guess the simplest would be to look ahead at the next one. Right? Then we can get our equals. I guess we'll just string compare this. Okay, here's the problem. We don't have the contents of the next one. So maybe we should write a custom string compare that takes in a string span. I guess 10 finger is a typing style. Do some people not use all 10 fingers? Where'd I go? Okay. So problem is we don't have the, okay, so we're gonna write a custom string compare really quick. Strings equal p. Sure. And I think we're just gonna do this, right? And then call string compare. I guess we could write a very custom one. I guess it's not even a string span, it's just 2 pointers. So we get 2 pointers. We need to compare them to a string. Okay. If not string, or not beginning, or not end, none of this will work. I guess we'll return 0. So at return Boolean-like value, 1 for success, 0 for failure. That's good enough for me. While string and beginning is less than end, beginning plus plus, string plus plus, right? And then say if string is not equal beginning. Let's see. So then we can just return 0 for failure. Return 1 by default. String, and I'm just going to call this strings equal p. I don't know what to call this beginning end pointer nonsense. So while string and beginning is less than end, I think this works. I guess, should I also test beginning for being an end of a string in case end is malformed? I don't think we need to do that. I don't think that would do anything. Okay, let's try that, I guess. So does this even work now is what we're wondering. If string equals strings equal p. Okay, that's an interesting one. Found a token blah. What is this, count? I keep track of this here? I don't keep track of the count here. It might be not a bad idea to convert these linked lists into an array if we're going to loop over them multiple times. But I don't think we need to do that because we just need to test that a colon is the same as the beginning. Okay, like that. Found blah. That token. Okay, we're looking for some. How many do we have? One, two, three, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Hey, haha. We did it. So we now no longer need to do all this nonsense. That's very nice. This can go back in there. And then we can do something like this. So I would like to compare if there's an equals in the next one. Okay, I have an idea for some tokens. We can create a macro for ourselves called like peak1. Yes, I think that would be fine. It will take in a token and it will just say, how should we do this? We could just return token next. Like that. Sure. I think this is just how that would work. We can't peek backwards, which is kind of unfortunate. This may become a doubly linked list. Or just an array is really what we should have, but it's fine. I don't think I need these. After writing them, I'm realizing, I can just write next. It's fine. It's not really that big of a deal. Because I already have to do the check myself here. I think that's not too bad. That's pretty ugly. I don't know if I like that. I think we're going to stick with it all on one line like that. Perfect. Super long line. Why not? Over 100 characters. So, okay. So this will let us... Ooh, you know why I wish I... There is a name for this. It's called token. String equal. This will be easy. This will make a lot more sense. Token. We're going to need an iterator. This token, if we dereference the pointer that we're given, will actually change it, which we don't want to do. So now we change this. And the string on the stack that we're given, yes, the string pointer. Okay. So now we can actually make a little bit of sense. I was wondering why these lines were getting so long. I'm like, I must have done something egregious. But I wrote a function in a too generalized way. I should have wrote it specifically for what I needed. This is much easier to read and understand. So if we have a colon and an equals next, then that means that this is an assignment. Yes. Okay. We should also say, is it a type name, right? So to do make helper to check if string is type name. For now, we're just going to say the same thing we did before. I think this can be an else if. And this, we would like to... Ooh. Okay, I accidentally opened Photoshop. Look at me. You guys can't see it because you're looking at Emacs only, but I don't know what buttons I pressed, but Photoshop opened on my computer. That's interesting. So we would also like to check if the next one is equal to integer, right? Found, hopefully, a variable declaration. Is there any case in which an unnamed variable is okay? Should this be an acceptable thing? We would just create a variable with no name. I don't think that would work in our symbol table or our environment. I mean, we could just treat it as a variable, the unnamed variable. There could be a singular unnamed variable, and you could just assign to it like that. I don't think that's a good idea, though. So we need to look backwards a token. So maybe we construct a linked list into an array. That way we don't do a bunch of reallocating. We allocate these small pieces. We figure out their total size. Unnamed variable. Wow. Because the token is a linked list, we can only look forward. So if we have an assignment, we could say like, well, if we never look backwards, or a variable declaration, for example, if we never look backwards, there might just be nothing there, right? We're gonna have to look backwards eventually, but it would be interesting just having an unnamed variable present in every environment. It's not a bad idea. Let's add that to my dumb to-do. All right. Ooh, we have to load org mode. Takes a few seconds, everybody. If you are a first-time viewer or just watching the channel, be sure to check out the Discord down below. You'll be notified every time I go live. I make announcements. We can chat together. It's a lot of fun. See, 2 of you are online. I really appreciate it. Morik and Polyvoid. Sweet names. But we have a fun time there. You can see some of my output from programs. My suicidal bot. You can see how suicidal it is. You can read about it. It's fun times. We have fun times. So I'm just going to call this... Ooh. Did I just spell that right on the first try? I hope so. That would be baller. I'm the type of guy that spells miscellaneous on the first try. That's what should be on like my dating profile. It'll just I'll be flooded with messages. What was I gonna say? I wanted to say that unnamed variable. That would be cool. Cool if an assignment and or variable declaration could have no identifier and work on a singular unnamed variable in the environment. I think that's enough for me to understand. Okay, so we can find an assignment. We can't find an assignment. Oh, we do. I just screwed up and didn't put a new line and got a little confused. That's better. Look at that. So, what's the name of your language? Chat gets to choose. I haven't picked. It's up to y'all. Cause I just want to make a compiler. The language can be named whatever. Okay, so now we have a list of tokens. I don't think so we can find a variable declaration and an assignment, I think in the proper order. Variable declaration, assignment, variable declaration, assignment. And then it even finds these variable declarations within the function definition. Okay. That's a pretty good start. We should start making use of this node and also make free node. But yeah, the name of the language can be anything. Viewers get to choose. We are going to code the freeing of the allocated nodes. So we're basically just going to say free root at the end and say while root children. Sure. So this is going to be interesting. So we have a node. This is an array of children, a dynamic array in C of children. So are we going to allocate we're basically going to realloc if children already exist and we add one, we'd have to realloc. I don't think that's the end of the world, because these are just nodes, not nodes, node pointers that we're allocating. So that's 8 bytes at maximum today. See, in our case, it's 4 bytes plus 4 of padding. So this really should be fine. We just need to say we just have to have a null child. So, okay, so we should say if his children, the top level pointer children, may be null. So we should say if root children. Then, if we can dereference this pointer, we can dereference children, and that isn't null, then that means there's actually a node child at this address. Is this correct? The type system is agreeing with me. Then we say while child plus plus, because we allocate a pointer next to this one, so going up 1. I don't think that's going to work, because it's not going to lay out when I allocate a node. It's not going to save memory for me at the end of this. So this pointer is going to move, but okay. Should we just implement like a linked list within each node of children? What would that look like? So each child has to have its own children. There also has to be multiple children on one node. So even, okay, I'm just gonna sketch something out loud because I'm thinking in my head too much. So I have node, and I would like children, these. Oops, I'll do one of these. Sure. Let's just number them for now. You always number your children, right? That's how you remember them. I like numbering my children versus naming them. Makes it easier. Names are really just fancy numbers, right? So conceptualizing this in a different way. Each one of these could have their own children, and the amount of them this way. So this is children, but this 0 needs to have its own children. Do you see where I'm getting at? Why this is just confusing me slightly. Not confusing me, but making me think, which I kind of appreciate. So then if this had 3, 4, let's say we move this a little further. How do we do this? So node has a pointer to a linked list of children. Okay, I get it. If we look at a singular node in the most complicated case, see, this wouldn't be like that. This wouldn't be possible. It would be written like that. Aha. Okay. Okay. So this would effectively, here, let's try and update this tree to match. So then 0 would have 2 coming out of it, I believe. 3 and 4. So this tree can be implemented like this. I believe that makes sense. I'm doing ASCII art again. I'm an artiste. You know why? Because it gets me excited. Oh, we're having fun. We're having fun. So this node structure that looks like this, I think can be implemented. Hey there, boss. What's up, Tree Mosher? It's so good to see you. We met yesterday. You are an artist, and it's getting me excited. I'm glad. I'm glad. Let's all get excited together. How's it going, Tree Mosher? I believe it's afternoon time for you, if I remember correctly. How was your day? We can't just have a pointer to children. Well, we do just have a regular pointer to children. Pretty darn good. No, it's 9 a.m. Nice. I forgot. We're in the we're in the tame. We're in the same time zone. Because it is also 9 a.m. for me. There's so many people with different time zones. It's like, okay, I gotta figure out different greetings other than good morning or good afternoon. It's like, ooh, good, because you can't say good day. It's kind of a little rude. It's 7:19 p.m. for me. Oh, Christ. See, this is what I like about Twitch. We get to share the world. Like, there's people hanging out, but we're nowhere near each other. We're in different countries and different continents, and we're just hanging out. Thanks to you. I spent about 2 hours comparing Vim and Emacs. Emacs is definitely way more in line with what I'm looking for. I want to do everything from there. Awesome, my guy. I'm glad I could help you discover this new facet, this new text editor. It's really incredible. If I do get to scratch my own back here. Okay. That's really awesome, Tree Mosher. I always love seeing more people in the Emacs community. It's really been blossoming recently in these past few years. I want to switch to Emacs too. You can. You can even just use it for like daily stuff. Like I use it to take notes, and I use it to keep track of ideas. And there's all sorts of ways to configure that, like org roam, org capture, or there's like Helm, I believe. There's denote, which is really good. That's the new one from Protesilaus. He is amazing. You should check him out on YouTube. He has amazing Lisp Emacs. Here, let's just go find Protesilaus. We like Protesilaus. Close. Emacs. Perfect. Okay. We're not going to play his videos so that we don't get copyright striked or anything, a copyright strike. But he has amazing videos on Emacs. And here, I'll link this in chat. He has amazing videos on Emacs, how he creates packages, and a lot of stuff you can do in it. It's really good. He has a thick Greek accent, and he speaks English in most of it. So it may be a little tough to understand in parts, but the code speaks for itself. He writes amazing code, and he's really eloquent. He says things in a really cool way that help me understand things. But yeah, like GNUs, you can read the news and like get emails through Emacs. Org capture. This video helped me with note-taking so much. Planning to start on the Emacs tutorial tonight. With the tutorial plus those videos, do you have any other recommended resources for learning? Ooh, I'm trying to remember when I first started what helped the most. So I think there's like Za keys or something. Yeah. Okay. Oh, Christ. Here we go. This, it's not secure, so it's an HTTP only website, but I go here all the time. I can always ask Google if you're not sure. Absolutely, my guy. I do remember using this quite frequently, and it has a lot of stuff in these little tutorials that helps a lot, like setting up key bindings. Oh, they sell it now. I'm not going to link that. That's hilarious. So before, this was all free, and you could just go here. That's sad. Or this is a copy, and I went to the wrong website. There's a little bit here, but it's not what it used to be. Yeah, this is closer. But now, yeah, he took out most of it. Okay, that's okay. It's I recommend just the built-in tutorial, and also use help within Emacs. So if you press Control H, there's actually all these different keys you can press. By the way, just getting this package that shows what key bindings you can press next helps a lot. If I think that's called Keynote. Oh, but you can describe all sorts of things. So let's see, if we press C, then it says describe the following key, mouse click, or menu item. So anything I press next, it's going to tell me what it does. So let's press like Alt X. Alt X runs the command execute extended command. Okay, what's execute extended command? Well, we can get help on that by pressing Control H, then F, which runs describe function, and then look at execute extended command. And if we look at this, we can see execute extended command is an interactive native compiled Lisp function in simple.l. And if you press enter on this link, here it is. You can read the Lisp code for that command. So now you know exactly what Alt-X does. And you can read their docstring. Read a command name, then read the arguments and call the command. To pass a prefix argument to the command you are invoking, give a prefix argument to it. You can type in the command name for translation. Exactly, so execute extended command allows you to press Alt-X, and you see the ones I used here. I can use align regex, for example. So if these are all out of line, I can say align on the regular expression, right, by typing Alt-X, execute extended command, and then align regex. And now I want to align on node underscore, and Emacs just aligned all these for me. I also have keybinds to create more cursors and stuff. So I can also do things like that, where even if they're all out of sync, like this, I can select them like that. So now I have cursors at each place. And then I can just press Control I, and it will fix itself with automatic indenting. But yeah, Emacs is very cool. You can have multiple cursors. I can also, I think, Alt click. Yep. You can click new cursors in and move them all around, type at each one. So it's a lot like the other IDEs. It just requires a little bit more interaction with the text editor, because you have to write the keybind yourself and find the package that inserts multiple cursors yourself. But that means if you don't want it, you also don't need it. Doesn't have to be in there. It's really cool. There's no forced features except for text editing. So with these two pointers, I believe we can have a child point to the next child, and we can also have each of these children have children with this pointer, right? I believe that works. I believe that works. MNTRA. I personally prefer a simple formatter keybind. First time chat from MNTRA. Maybe mantra? It's great to see you, man. How are you enjoying us making a compiler today? And also, I've seen that a lot where people add in, like when they press save, that they run like Clang format or some other code formatter on the file so that it automatically gets formatted how they prefer. But I prefer manually formatting things because I like things like this where they're aligned vertically. I wish I could do it for the arguments, but a function like macro definition needs these bunched up next to each other. At least on my machine with my compiler. So with children and next child, we should still be at 24 bytes because there was 4 bytes of padding before. But now we should be able to, represent a complex tree with any amount of children. And each of the children is a node itself that can then also have more children with the next child. Okay, yep, I believe this works. Because the node only, we could also save parent. That may not be a bad idea. We'll see what we need. Possible to do. All right, perfect. Okay, yes, I changed how this works. I was like, wait, what's going on? So we would like to say if root children, then we can say, okay, let's create a node pointer, and this will be like an iterator. How are you allocating your nodes? Are you using an arena of some kind? No, I'm using nothing so far. I don't think we've made it to allocating nodes. See, we just have print statements. We've just gotten to the point, because this is only the like 5th hour that we've been working on this, probably even less, because I only work on it on stream. But you can see we are just now comparing tokens and finding expressions. So we're not allocating nodes yet, but for now we're just going to use malloc is how we're going to allocate them. I just want to make sure that I free everything I allocate. So we're going to say child equals children, while child, I guess this would work like this as well. We should say if not root return. So for each child, what would I like to do? I could just call node free on it. That's very recursive and not good at all. Could we do a continuation here somehow? Let's see, what do we actually need to do for the child? We need to free its children, only if it has children. Then this will eventually free it. Okay, that's kind of what this function does. I think this isn't too bad. We can use a continuation eventually by having a higher level while loop. But I don't think that's, we need to do that right now. We're just gonna not worry about performance because I don't think anybody's gonna be writing thousands of lines of code in this unnamed language. I'm off. You guys have fun. All right. Thank you so much, Angel. I really appreciate you coming out. Thank you for watching. Hopefully you enjoyed some of the compiler. I know you're already in the Discord. I am very glad that you did so. And I will see you next time I stream, hopefully. Thank you for coming out. Buffer all the pointers that need to be freed and then free them all in one go, maybe. So I'd need like a linked list of pointers or some other data structure I can write myself, but I think a linked list would be the fastest. And I could construct a linked list by traversing the tree. I like how you think, Mantra. I like how you think. Let's do that. So let's put that in a to-do. We'll do that some other time. We're gonna try and make some more progress right now. So to-do would be make more efficient. How do you spell that? Mantra on Twitch suggests keeping track of allocated pointers and then freeing all in one go. I like that a lot. Perfect. Okay, so this should free everything, right? So for every child, we free its children. But we're going to use after free here. So we need to keep track of the next child. Next equals. I don't know if that's not null yet. So I'm just going to say this equals null. We're going to say next equals child. Next child. Lamau. Listen, at least we caught it, right? At least we realized. So we are freeing a root, if not root return. The child is the children. The next child, it's kind of confusing. The next child, just an idea for your current implementation. Ideally, you would allocate the tree in an arena and just clear it in one go when you're done. Yes, but I don't want to code an arena allocator right now. I want to code a compiler. I see what you're getting at, though. That is much more efficient. So we basically just, let's see, free the root, get the child. Next child is null. Next child is equal to the child, next child. Then we free this pointer, so we do no more dereferencing of it after this point. That's correct. Then we free the root. So in the child, we'll go here, return here. I think that works. Hopefully. Windows definitely crashes when you free the wrong address, so we'll know. Where's we parsing? Free the tokens. Free, I guess I called it node free. This is all over the place. Yep. Hopefully, we make it. Hey, haha, we didn't crash. And on Windows, that, especially with an untrusted process, that generally means you didn't screw up the heap. Awesome. Okay, hopefully. I mean, I know we're not freeing any children yet, but it's working. We didn't screw it up completely. There's not an infinite loop. We're doing okay. So we found an assignment, not necessarily a valid assignment, because we don't know what's after the equals or before it. So we need to do some testing here. I'm thinking that the tokens... Okay, so currently we have a terrible token implementation in the form of a linked list. So what we would like to do is either not use strings for tokens the way we are doing it, and we could just have like an enum, and then the Lexer could be able to spit out like, hey, this is unrecognized. We don't know what the hell this is. But we also need strings on tokens for data because, for example, an identifier, we need to keep track of what the identifier is. So kind of having that is important. And I don't think it's really that bad to have, because these are just views, they're not allocated. So our token is basically a linked list of string views. And what we would like to do, let's see, we have a token. We can create them with the Lexer. We need to convert them into nodes using the parser. And the problem that I'm running into is that I need to peek backwards on the tokens. All right, now we're getting somewhere. I'm getting there. So to peek backwards, it would imply, whoops, that we either have a doubly linked list and we have a token point both ways. Token. Or we could have, let's see. We could convert, okay, we keep track of how many tokens there are. We can do, because we just do this here. Probably more efficient. So now that we know how many tokens there are, is this the right count? Should count start at 1? I don't think it should, because we start with null. We'll create 1 and then say plus plus. Add 1, say plus plus. I think this will work. So we keep track of how many we have. We can definitely do that here. Little printf debugging to make sure we're not insane. 31 tokens and token 31. Wonderful. So now that we have a token count, we could just allocate an array of the entire, the size of the entire tokens, and then copy each one into the array, which I think may be what I do. That's not a terrible idea, I don't think. I mean, it is a terrible idea, but it's my terrible idea, so I'm going to run with it. Token array, why not? That worked pretty good. I guess calc is literally made for this. We should use that. Also, sure. No. While, okay, so I'm going to do a similar thing to here. I'm just going to assert that that works, by the way. Why not stream the tokens? Stream the tokens. So only lex them as we need them, is what you're saying? We could do that. It would also work. Each token should have an enum variant and a span in the source code. My guy, I know. I've created languages, I've created compilers. I just want to create one fast and fun. I ain't trying to do it the right way. No need to allocate anything in the tokenizer. I know, I just went over that, my guy. I said, I have a linked list of tokens, and that's what I construct. But I should probably just convert it into an array. Or, what you're saying is, don't create any list whatsoever, and only parse them as you need them. But how do we look backwards in that scenario? Like, how do we peek backwards? Like we would have to keep track of the last, I guess we could have a window of the last 8 tokens or whatever that we've seen so that we can peek backwards that amount. Is chat happy with that? Instead of this loop, the more allocating, because I can tell you're a memory allocation guy. You don't like it. You want to, or girl. You can be any type of person. They. So if you don't say guy or girl, should I say non-binary? Should I say guy, girl, or non-binary? I feel like that's just another specific one. So I tend to say guy, girl, or whatever else people want to be called. That was a tangent. Just saying, if chat is happy with it, we will keep a window of the previous 8 tokens we've seen, and we will stream the tokens, aka only Lex, as we need them. Yes? Happy? I think you're happy. Okay, so instead of constructing a linked list, then looping over the list, we're going to stream. I'm a guy, Lamau. I-80. I will use male and masculine pronouns, my guy. He, him. Mustache. I don't know. Okay, so let's see. Did I finish that? Oh, I got rid of it. Okay. So Mr. Mantra says we should stream the tokens and not Lex them. So what we're going to do is not do any of this. That's fine. And if you want the original string back, just use the span to index into the source code. Oh, I know, my guy. This is what the beginning and end is. That's how we're lexing. We just return a beginning and an end from the Lexer. The Lexer is a streaming Lexer that we built, if we look. See? We take a token pointer, but just to write into it. See, we set the beginning to the beginning, and then we skip past our token, and then we set the end to the first delimiter, like that. And then source is set to the end of the last token, usually, in the parser. If we take a look. See? So we have the API for it. We have the idea. We're just going to do it in a less memory-heavy way to please Mr. Mantra. So effectively, let's see, if we get a current token, we need to add it to the list of previous tokens once we're done with it, I presume. And while we're using it, we may need to lex more tokens. Which is a fascinating idea to me. So we could go state machine, which is basically continuations in a nutshell. Or we could go lex into current token after copying current token. Okay, because we don't have to lex into current token, we can create a new token and lex into that to peek forward. Alright, so peek forward would be just lexing more tokens and hoping that it's the right type. Which currently we're just doing with string compare. We'll eventually probably make that an enum or something that the Lexer sets once it has some more data. Or we understand what the language looks like. this unnamed just for fun language. Alrighty. I think I'm going to do a similar thing to here, where we're going to loop until there are no more tokens to get. I should really have like an error check macro that I can just put an expression into and the name of an error, and it'll only accept it if it's none. In any case, we now need to set, okay, our break case. So now, if we lex nothing, we get the hell out of there. That seems valid to me. So now, yes, I know, you're angry. We'll use you soon. Yes, I know. We'll just do something like that. Ooh, that didn't work. There we go. Perfect. Does that go there? I think that goes there. Probably then remove 2 spaces. That seems like it makes more sense. See, the confusing thing is there's also comments here. How did this get double commented out? I don't even know. Jesus. That's fixed. I know it's code that doesn't matter, but what are you mad about? Root doesn't exist. Okay, you go too then. You're a part of that crowd. So the idea is that as we stream tokens, we're going to create and allocate an AST. Sure. One size of node. I just don't want to call memset 0 or initialize it. So we have a root, and effectively, I think what we want is something like the root. Ooh, I gotta turn off company mode in the scratch buffer. Why does that happen? Okay, I'll use Control O. Some indenting. So we're gonna assume that expressions go here or whatever. The program body, right? And hopefully the root doesn't have multiple children. I guess it could have multiple children in the sense that it has the body, which is like a linked list of expressions or statements, a sequence to be evaluated or compiled or whatever, executed. Okay, so with our root having the program body, let's say if we had like 2 plus 2, let's just kind of figure this out. We're going to need to encounter the plus and then create a child. And with plus, I guess it doesn't matter which way they go. So we can just look forward 1 and make sure it's an integer 2. But, oh, I write it on the same line. And then we have to look backward 1, check if that's an integer for type checking, and then create another child of the plus. Okay, this is understandable. We now need a node pointer array called like lookback. Sure. We are just going to do a const size t. Lookback size equals 8. That way if we need to loop over these, or we need to know how far we can look back, we can. Okay, I'd just now like to assert root and look back. Like for root AST node, sure. So now, if this token, yep, we're basically here. Also, we could say, so we're gonna have to loop over look back and move them all back one. Oof, cannot type. Size t I equals 1, I is less than look back size plus plus I. Okay. Could probably pass that as a stack object. Doesn't matter. Pointers are smaller anyway. So for size t I equals 1, and look back at I minus 1 is going to equal look back at I. So this should shift the entire look back array back by 1. Perfect. And then at the end, we want this to equal the node. So maybe this should be like working node. I guess we're gonna need an iterator then as we create them. Sure. Probably gonna be like that. What do we got? Yes. Type equals node type. None. Sure. Could also just mem set it, but this works fine. Explicitly initializing it. Okay, so now by the time we get here, we should have set up working node to be, okay, this isn't gonna work. Why am I an idiot? I'm pretty sure look back is of tokens. The problem with C is to get the functionality you need, you have to manually implement a lot of things. Exactly. I do like that. That's actually why I like C, because I hate having to rely on like data structures that I don't understand. I want to inherently understand them and be able to like draw them out without having to look up how they work. It just is it's why I like to do this. Do you prefer C over C like C++? I mean, I wrote an OS in C++. I don't dislike C++, but I do like C a lot because it's just so basic, but so powerful. I feel like C is going to be around for a long, long time. I do think I'm an idiot because I don't think I need to look back at nodes. I think I need to look back at tokens. Ain't that wonderful? It's fine. Whoops. All right. 4. Yep, I know. Just gonna assert the root whatever. Why do you need to look back? So this scenario right here, we don't know that we're doing an addition until we get to the plus. Because I don't want to have like Lisp. Lisp has +2, 2. And we can just evaluate that. And it's fine. Right? And it can know, okay, we're doing a plus, collect the arguments, apply them, whatever, bind them in an environment. 2 + 2 is a little different because parsing wise, you hit 2. That's not an interesting token, it's just an integer. You can't really know that you're about to add 2 integers by hitting 2. So you hit plus and then you go, okay, but behind us, we need an integer. So hitting plus requires type checking that 2 is an integer. And then we're also going to have to look forward. If we didn't need to look back, then we could just use the linked list we had before. It wouldn't be an issue. Do you have a magical solution to never look back? It would be cool. Magic Man in Twitch chat. Fix this program. Yes, that's not going to work. So we're gonna have a bunch of tokens. Should we just, I mean, we could ideally at this size, we could even do like just an array. I'll just do this, it's fine. It works the same way as an array anyway. It's just heap allocated instead of stack allocated. So we now have an assignment, let's say. So let's look at our example. So we need to look back to get our data for our symbol. And then we also need to look forward and ensure that we have a type name. Alrighty. And also this should be current token. And I think I'm gonna have to like do something like this. Is this a pointer? No. We'll just do an array. It really doesn't matter. Sure. We'll go here. Okay, we still need look back size, but it's gonna have to be a thing. This is terrible. Don't at me. Okay. Beautiful stuff. So now our current token is copied into this look back array at the end. So to look back, we can just use look back size -1. So however many we need from the end. The first one from the end. Okay. Okay. So now we effectively need to move forwards. We're going to have to create a token equals. Tried to write a REST parser in Rust a while back, and for expressions, I ended up just checking for binary expressions every time I parsed an expression, so I didn't need to look back, so to speak. Checking for binary expressions every time I parsed an expression. Yikes. Okay, so you're saying that every time you parsed an integer, you just looked forward for a binary expression like plus, minus, divide, etc. So does that mean at every unknown symbol, you would look forward for an assignment operator? Is that what you're saying? So you'd say, okay, we're not at one of these. We're not at one of these. We're not at a type name. We have this unknown string of characters, like A. an A would just look forward for the colon. We could do that. I see. Okay. So then we would have this unknown. I parsed the left-hand side operand and had its pointer on the stack and peeked for a binary operator. And if there was one, I recursed the parse expression again. Right. That's a recursive descent parser. Yes. So parse the left-hand side operand and had its pointer on the stack and peeked for a binary operator. And if there was one, I recursed the parse expression again. My guy, we're just going to do what you say, because this really doesn't matter. Let's do it. We'll never look back. Mantra has taught us, never look back. You never need to look back. It's not important. You don't need to write code. You don't need to make progress. You need to bike shed and write the best code, right? Yeah, let's do it. All right, so effectively, Mr. Parser wants to look forward, and this would effectively mean that every time we get here, we basically just need to say it doesn't equal any operators, and it doesn't equal. So we have delimiters, I believe. Yes. So if the token contains any delimiters from the Lexer, well, the token can't contain delimiters. That's kind of how that works, unless it is a delimiter itself. Well, that's handy. So to check for a delimiter, I'm going to say if current token, I guess we're going to have to figure out how to do this with a string span, right? Let's see. Because how do we ensure that we don't have a malformed operator? Because if we just treat every token. Mantra? Okay, do you understand how a variable assignment is a binary operation? Seems you're using colon too. Yes, any token can be used in the middle of a binary operation. But when you assign to A, if you assign 0 to it, you need A, you need 0, and there's something in the middle. That's a binary operation, right? So how do we detect that we don't have something like this? Right? Because we don't want this to work necessarily. Sure, I do have that syntax. So when we assign here, we need to make sure that the first thing we've hit is an unknown operator. So we need to make sure that it doesn't contain any delimiters, because if it's a delimiter, that means it's an operator, most likely, right? So how do we ensure that this operator doesn't get hit first before an actual integer? Or do you just ignore it when you don't know what it is and move on? Right? So we could also say, okay, if a token is an integer, then what we could do is look forward. Otherwise, continue. And otherwise, just error out because it's an unrecognized expression. That seems like that would work. When you enter parse expression, you need to call a parse operand function. No, I don't. Stop telling me what to name things, please. Right? That's one way to do it. I understand. If you want to backseat, code, go to another streamer. I won't even point you to the Discord down below, because I don't want you. You're just going to tell me what to do. Say, oh, no, do it this way. No, do it this way. It's the idea I'm talking about. Cool. You don't need to do that. You could have the function parse operand inlined as part of your parse expression. It doesn't matter. You could parse operands in a completely different way. There's a whole bunch of ways to do things. I'm exploring new ways to do things because I've done this before. I've made a recursive descent parser. It's not difficult. It's not what I'm trying to do here. Okay? I'm not just trying to do, oh, yeah, let's just follow this tutorial because there's a million tutorials on recursive descent parsers. Not literally, except it is literally. You're describing a recursive descent parser. Pretty much exactly. So I'm just trying to create something here. I'm not trying to follow your tutorial and make code that is acceptable and matches yours exactly in Rust or whatever. Okay? I don't need to call a function parse operand, and I don't need to call it at the beginning. I'm going to do it however I do it. That may be how I end up doing it, but I'm going to get there on my own, my guy. I'm not just going to do things because I don't understand them. Like, oh yeah, let's just add parse operand. This will help. Cool. We did it at the beginning. That doesn't help me, my guy. You're just saying, do it this way. It's the right way. It's not the right way. There's any way that works is the right way. Alrighty? Okay. Now, we're basically going to use A2I, if I believe correctly. So A2I, convert string to integer. That's exactly what I need. Is there like a tall? What's our integer type? Long. What's a long? Can we do a tool? We do. Wonderful. Okay, so we can use a tall. A 0 value is returned. Okay, so we just need to check if it's an integer. We're going to have 0 check and then strtall. Right? Alrighty, that seems like it's going to work. So if current token end minus current token, seems like we're going to use this a lot. Let's just get this length separately. Perfect. Token length equals 1 and token.beginning when dereferenced equals 0, then this would be 0 integer. Wonderful. And strtall needs a string with an end pointer and a radix. Okay. So the radix is going to be 10. We want a decimal number. See, strtall for a more robust cross-platform. Is that C++? Let's see. Is that what I typed unknowingly? It is what I typed unknowingly. Hilarious. I was looking at the documentation for atol, and I typed stirtol, and that's actually what I need. What do you know? We stumbled upon it. Let's see what we got. So parses the C string, interpreting its content as an integral number of the specified base radix, which is returned as value of type long int. If end pointer is not a null pointer, the function also sets the value of end pointer to point to the first character after the number. So that's a pointer that it sets. Okay. Operates like string to L to interpret the string, but produces numbers of type long int. So it returns 0. The function returns long max or long min, and errno is set to E range. Defined C limits. I think, this might be a C++11 thing, but I think it should be in C11 as well then. We'll see. So let's give it a pointer. We can pass null as the second one. And we should get this value as a thing. Can I create a node value like this? Is that possible? That would be cool. We'll try it. I can also just set this in the working node, is what I'm realizing. Perfect. Value.type. Nope, .type equals, what is it? Node type integer. Hey, we're starting. Root type equals node type program. Cool. Alrighty tidy. We have printf the 0 integer. This is not a 0 integer. Count integer blah. That long? I forget. Is it LLD? Okay, so we have working node.value.integer. Wonderful. And then we can stirtle. Stirtle like a turtle. It will return what we need. So we need a string, which is going to be the current token string, and radix 10. And if this does not equal 0, hello, what? So this is a function call assigned to this value, which is then not equal to 0. What's your problem? Too few arguments to function call. Oh, okay, yep. I gotta pass null. Aha, you did it. Hopefully, that would work. Okay. We have 3 0 integers. We do. Hey. 420, 69, and 42, the meaning of life, the universe, and everything. Hey, look, we're parsing integers. Look at us. And we don't call parse operand at the beginning. Look at that. It's a miracle. Fuck. Okay. So we would effectively like to pass in our node and our token and kind of say populate that boy with an integer. Let's try that. So we're going to have void parse integer. We're going to have a token and a node. And basically, the node I guess I could return like something. Return Boolean like value. 1 upon success. 0 failure. Wonderful. So, token. We want to basically do these two things. So let me just, nope, not those two things, these two things. Steal these. And token length. Token. It's a pointer. This is just called node, and it is also a pointer. We'd like to set its value and everything. So we have to handle 0 specifically. So we have handled 0. We have handled numbers themselves. We can dereference so that we update this memory for everybody. So, and the value is already set by strudel. But each of these should probably return success, right? Should these ever fail? Well, if none of these, I think that makes sense. Yeah, because if no integer is found, return 0 for failure. Makes sense to me. Okay. Now we can parse integer from our current token into our working node. And if that happens, then I don't know, we have an integer. Make like a print node, maybe? That'd be a good idea. Let's think about that. Let's think about making a print node. Let's call it like node print. Well, what did I call other things? Yeah, I have print underscore. That makes sense. So print node. Let's go and look at how node is defined and how we can print it. Okay, so first of all, I feel like we should have the value followed by the type. We're gonna have to do a switch on the given node. So let's just say root. Not root, just return. What's your issue? Can you automatically? Is there code actions here? Can I do that? No. Tried. Okay, so all we need is to handle the node types. So we can assert that node type max equals 3. Node must handle all node types. So this message will help a developer when compiling know what to change. Print none kind of directly. Oops. Unknown node. Okay. We'll just put integer. That's good enough. Program doesn't have a value. So we can also probably write the values here. There's no reason we can't. And this would be the node value integer. That's better. None, that is its value. Unknown, sure. Okay. We should probably also have like a something like this. And then for the indent level, we indent that many characters. Wonderful. Awesome. So when we print a node, we indent it this many indents. So now we just have to say, I believe, a new line. Print something like that. And, well, I guess, let's see. For each child, we'll just print something like that. It's not going to be pretty, but we can do it. So while child, then we're going to need a node for the child. Didn't we do this before? Something like that. Hey, look, it's right below. It equals node children. Next child equals null. So instead of freeing, we can loop over each child and print this. We're also going to have to print the indent level again after the new line. Print indent. That's print type and value. Print indent. Children. So for every child, what if we did this indent for every child? I think that's reasonable. So we indent the same amount as the parent, and then how long is that? 4? So we should get our current indent level plus 4, and that's where this should be written at, no? Here's the thing, this is kind of a part of this. So we need to print a singular node, but we need to print the node of each child kind of specifically. So this prints indent level. I think I can do something like this. And have this piece here. protect from null dereferencing. So now, this is kind of confusing. That's better. So we can now print just the node. That's very handy. Because when we call this, what we would like to do is indent, print the parent, make a new line. Excuse me. So then for each child, we can indent, put this, and then here's the thing, we need to print the children of each as well. Man, that's difficult. So what if I just did this? It didn't do that. We're gonna try it. Hey, it worked. All right. So if parse integer, do something. Probably look ahead for binary ops that include integers, I guess. Yeah, this is good. So we can parse ahead that way, thanks to Mr. Stubborn Mantra. And we can print every note we find. We have to reset the working node every time. Lots of undefined nodes that aren't handled. Okay. So when we now parse an integer, we can look ahead for binary operators. So if we don't parse an integer, what else are we looking for? Well, for now, what are you building? Hello, Mr. Mugame. Thank you for chatting. I see it's your first time around here. Mr. Mugame or Mugame, whatever it is. I am building a compiler for fun. I just woke up yesterday, I wanted to build a compiler, and now that's what we're doing. It's been fun. How are you doing today, my guy? Thank you for dropping into the stream. So, let's see. I'm great, thanks for asking. Of course. I am happy to have you here. If you end up liking what you see, be sure to hit that follow button. Or down below, we have a Discord. You can join that, chat with the other people that watch, chat with me, and get announcements every time I go live. In any case, we need to continue work on this parsing into an AST. So we generate an abstract syntax tree based on what? So if we parse an integer at the top level, we need to look ahead for binary ops that include integers to find expressions. So then we need to say like token operator. And then we could parse into that and do something like this. Dot type does not equal error none. We should probably like error out or something. Do. I'll just print an error and return. I don't know. Can I just return the error? That'd be nice. I can. That's why we What target are you compiling to? Code generation wise or like machine wise? Because machine wise, I plan to have it cross-platform Windows, Linux, modern OSs. You know what I mean? x86, 64, 64-bit machines. But if you're asking like what language or literally what we're compiling into, we haven't generated any code yet. We don't have the code gen stage up and running, so we don't know. And in case you didn't know, this is a compiler for fun, and I don't really have a plan. We're kind of just making a compiler, if that makes sense. And we're doing it with no dependencies in C for fun. Did I put this in the wrong spot? I believe I did. Unrecognized token. Token. I see, that was back when it was a linked list still. There's no longer a linked list. We do different. So what do? We just need to print. Here, let's just leave this how it is. And do one of these. %.star_s t end minus t beginning, t.beginning. So we now print the string span, and I think that's all we need to print. It's good enough for me. If writing a compiler from scratch in C is your idea of fun, I'm worried about you. First time chat from Axe. That's valid. That's valid. That is what's fun to me, though. I've got nothing else to do in this life. What do you find fun, Axie? Thanks for chatting, by the way. How are you doing? Oh, and with the follow, Axe with the follow. Thank you so much. I really appreciate the follow on Twitch. I don't know if you've heard the spiel yet, but down below there's a link to Discord where you can chat with other people that watch, you can message me, and you can get notified every time I go live because we make an announcement in the announcements channel. Fun stuff. All right, so unrecognized token. What do we do in this case? I don't know. Let's see how many we have. We have quite a lot. So unrecognized token A, found node none. So given an unrecognized token, we should eventually validate check if valid symbol for environment and attempt let's see, variable access declaration assignment. It's probably going to go first. So check if valid symbol for environment, then attempt variable access, attempt to pattern match variable access assignment declaration or initialization declaration with initialization. And return that expression. Doesn't sound too crazy now, does it? So let's keep track of integer. And just, can I copy these? He's using a mouse in Vim. He's the devil. This isn't Vim, my guy. This is Emacs. We write in Lisp around here. I wrote a whole text editor, my guy, based on Emacs. It's amazing. God. I don't use the mouse that often. What did I use the mouse for? I don't remember even taking my hands off the keyboard. Kappa. I thought it was dead, lol. Well, you are very mistaken. Emacs is amazing, my guy. If you think Emacs is dead, what rock are you living under? There's been more packages made in the past like 2 years than ever, pretty much. There's so many now. It's incredible. Melpa is filling. It's so awesome. So we copy our integer token, and then we try and lex, hopefully an operator. So the idea would be to do check for valid operator, integer operator. Could we define new operators within the language itself? That sounds fun. That would mean that we have to look up operators in the environment, which means we're going to have to do actual work on the environment. We should make it like a hash map too if we really want to do it the right way. So when we create an environment, we have a binding, and the binding has a character ID bound to a value. So what if this was just another node? I think that's fine. And then we will need a string or symbol type or something within our node. So now in our environment, we can have a binding from IDs to values. I guess this would be bindings. Because bindings next. Okay, so I get it. Let's think about this. We have an operator that we would like to have. But we need to check, so we need like a specific environment for operators. Right? If we want to do like the lookup by in the environment and have people be able to define new ones. So if we look up what the operator is in an environment, the operator environment, let's say, then we could create new bindings in there, or the user could, maybe through the code, and then you could redefine or define new operators. That sounds pretty cool. It sounds like we just need a way to access the environments. Okay. We have almost been streaming for 3 hours today, so we are definitely going to have to wrap up here soon. I'm going to aim for streaming till 11, so we got 20 more minutes here. But also 11 PST, I don't know what time that is for you. So in about 20 minutes, we're going to wrap up, but we will keep on working till the clock runs out. So if it's not an integer, we're just going to go ahead and assume that it's something unrecognized. Check if valid symbol for variable environment. So we're going to have multiple types of environments, I think, as this will allow for xvivbot. Hello! How's it going, xviv? We're just wrapping up this long stream today. We got about 20 minutes left, just so you know. How are you doing? I'm so glad you could make it back. Good. Awesome. I'm glad to hear you're doing good. Okay, okay. We've made some progress on the fun compiler. We're actually starting to parse, and we're not creating an AST, but we are creating nodes. You memed porth, kekw. How did I meme it, my guy? Maybe I memed it. I did get inspired by it. I was like, ooh, this porth is awesome. I want to make something like that. But I wanted to do it in C++. And I was like, okay. It would be funny if, because porth is based on fourth, it would be funny if corth, which is based on porth, which is based on fourth, kind of includes that kekw, Lamau. Thanks for checking out my other projects. Yeah, I definitely did that. I just thought it would be funny to mention the reality of it. Like, this is a language based on a language based on a language. It's not an original idea, but I'm not very proud of it. It's all in one file because I wanted to see, like, okay, what's the actual like amount of lines of code that is needed for a compiler? And it was it's about 2,000 is the answer. If you write a very shitty, terrible compiler like I did. But that was me basically learning C++, so I don't feel too bad about it. Okay. Parse an integer. Check for valid integer operator. It would be cool to pass operator to use an operator environment to look up. I'm just writing to do so I don't forget the ideas that I've had, because I am a forgetful boy. I do not remember. It would be cool to use an operator environment to look up operators instead of hard coding them. This would eventually allow for user-defined operators or stuff like that. For now, we're going to hard code. So, how did I compare a string? I didn't. I used strtl. That's fair. So I would like to compare the beginning of token yes. Okay, so we mem compare from current token beginning to current token end minus beginning. But where would we like to compare with? So we would like to compare with this other thing. String compare won't work. We'd have to use string n compare. That's not really, it's not really in my wheelhouse right now. So I don't know if that's cross-platform POSIX or not. Okay, so I would like to test if it's a plus. Kind of all I'm doing. This is horrible, but it's fine. So, for token length. Do I have the token length already? I do. So, if token length is greater than 1, I guess I can just compare 1. Because what's nice about this is I don't have to worry about, yeah, we're just going to go the very dumb way. The very, very dumb way. And if that equals a plus, hey, we're going to create a binary operation. I don't even know if I want to mock out this style. I don't really want to get that working. I want to get the environment stuff up and running because that's pretty important. We also are going to start needing a parser stack. Okie dokie, okie dokie. Environment. So when we want to set a new thing, we're going to have a node ID, a node value. I don't know what to take these by. We'll just keep it like that. So this will create a binding, but we're also going to need the environment we're binding within. And then we're going to say environment.bind is equal to a new binding. All right, sure. All right, so we have binding. Cool. We're also going to have free these environments, or we could allocate. We should probably just move to a hash map sooner rather than later, so that we just allocate a bunch of bindings all at once in our buckets and not have to worry about it, but it's fine. This is fine. Why are you mad about this? Oh, yes. That's a pointer. So a binding, I feel like, should just contain the nodes itself. What's in a node? See, nodes contain either a pointer to some garbage collected object in the future, but they just contain a value, children, and child. Okay. So we basically could have a node here, but just ensure that it's not a complex one. Or I guess we just, depending on what environment, it'll change. That's cool. That works. So binding. We create a binding. We need to assert that it exists, because memory allocation may fail. Good enough. Binding ID equals ID. A lot of copying going on around here. We could pass as pointers and then dereference here, but it would only save a few bytes worth of copying. I don't think it's really worth it at this time. Okay, now we just have to say binding next equals end.bind. I think we can have a stack-based environment. I don't think we need to heap allocate this actual object, just the bindings within it. The environment will just be a way to keep track of those allocated bindings. Let's say environment env. Env.bind equals null. Okie dokie. So because we can have parents, does this change the fact that it's stack-based? Well, we're going to pass null in here first. But then we're going to pass in this address on the stack to the unenvironment. So this does need to be heap allocated, I believe. Otherwise, we would keep getting the same address for the parent, and it wouldn't actually work. I always do that. Look at us. Environment create. We did it. So we mallocate some memory for an environment. We, once again, assert some more stuff. Hey, we need this. And then we return that. So we create a new environment with no bindings. That's wonderful. Then we can set within the environment. This is basically an associative list where the first matching ID will return the value. So get moves the value thing here. So we have a value. We would like to use our ID, binding pointer, binding iterator, which is equal to the first bind, and then we can say while that's not null, I think that's enough for me. Well, it's uninitialized. We should probably make the pointers null at least. And while we're at it, we can just set value to 0. Okay, so now, yes. Linked list, wonderful stuff. If node compare, how do I compare two nodes? I would like to check if these IDs are equal. So we're literally just gonna have to have a node compare. Is how that's gonna have to work. Also, I don't know if this quite works. I think I just don't need that at all. We'll see how that works. Okay, so now, where was I? What am I doing? Nodes. I need to make a node. And what does it have to do? Why am I doing this? Because in the environment, I need to compare, node compare. This will have the assert node type, max. All right, we're looking about 10 more minutes on this stream. Thank you everybody for watching so much, by the way. I really appreciate you sticking around. We're making progress on this compiler. We started with just a Lexer, and now we have some failing compilation, but now we have an actual parser slowly forming. It's very cool. So what would I like to say? Node compare. Handle all node types. Sure. Switch on the node type. Which node type? So we're going to have node A, node B. I guess I just should say if A type does not equal B type, and get out of here. Boolean like value. 1 for success. 0 for failure. Sure. So if they are both null, yes, they are matching. If only one is null, they are not matching. If their type does not match, they are not matching. Otherwise, So if they're both none, we can kind of just handle that. I think I can do none p. Does that work? Should work. Ah, but it's not on a pointer. It's not going to work. Not even like that? Hello? That should work. What's the issue? You have some issue? None p is invalid. Oh, it's below. I'm an idiot. I'm like, why is this not working? What? Okay, that should help a lot. What are you mad about? Not handled in switch. Okay. I don't really need max. I need integer. So to do, compare two programs. That would effectively be, so a program is just a list using the children of sequential expressions that need to be executed or evaluated or whatever. So eventually we'll have to go through and compare the entire list, which maybe program should just turn into a list type or a pair or something. Maybe we'll do a recursive pair, but we'll see. We'll see how it goes. So given an integer, so if they're both none, yes, they match, otherwise they don't. If a value integer equals a b integer, a b, what am I doing? A b value integer, there we go. Then these integers are matching, otherwise they are not matching. Does that make sense? We don't compare two programs yet, but I'm just going to do that as well. In case we ever actually get here, we'll see it. All right, we're coming up on our endpoint, and it just turned 11, so I'm glad we have all these to-do messages. We're going to have stuff to do tomorrow, or later today, or whenever I stream next. Be sure to join that Discord. It's a link down below, and you'll be able to be notified whenever I go live in this announcements channel. And it works much better than the Twitch notifications, so I really recommend that. As well as just chatting with everybody. We get to talk. You can message me, message each other, and make good friends. Thank you so much for watching. I really appreciate it. And I think, oh, let's make sure this compiles. Let's see why it doesn't. Let's do that first. That's why. That's not how you spell assert. In environment get, we aren't quite done yet. So we have to say if node compare finding it ID. Like that. Oop, what just happened? Not sure what just happened. Close this. There we go. So if we compare these and they are equal, ID matches, return value. So we can just return literally the value. Bye, Mr. Mugobo. Bye, Mr. XVivBot. We did this last part really quick, but we need to get it compiling. Otherwise, return like none, right? Yeah. I think, do we even need this? think that's just for that. That's perfect. Okay, we did it. Compile, please. It compiles. Yay. I will later today, when I have time, commit this into GitHub. I wasn't able to on stream today, but that's okay. And look, we are making progress. We are now creating, or at least finding nodes, parsing nodes out of tokens, and it's going well. I like it a lot. Thank you so much for coming out. Peace, and I will see you next time.
Bye bye.